Viewers, you're welcome to this lesson on artificial intelligence. My name remains Vincent Hope, your instructor. So let's jump right into it. So what is artificial intelligence? Now, we'll start by defining what human intelligence is. So human intelligence is the ability for humans to learn and do work. That is human intelligence. Now, if we make progress, and as human beings, we can learn how to drive a car, cook a meal, solve maths problems, dance, sing, write, discuss, etc. Now let's make progress. As humans, we learn by observation, practice, and also by instruction. So we go to class, the teachers instruct us on how to solve mathematical problems or carry out a task. Now let's make progress. Now, if we know that human intelligence is the ability for humans to learn and do work, then artificial intelligence is the ability of machines, now not humans, the ability of machines to learn and do work. That means if human intelligence is the ability of humans to learn and do work, artificial intelligence is the ability of machines to learn and do work. And what can machines do? Machines can drive cars, self-driving cars. We will see an example in a short video. Machines can also cook simple meals. You will see that also in a short video. Machines can also solve math problems like computers. Machines can compose music, which we will see in the course of the lesson. Machines can write, like computers can help you to write. Machines can also help you hold discussions like chatbots. If you go to sites that have chatbots and you type in a chat, you will discover the chatbot is going to give you a response. That is AI working. Now, so these are the things AI can help you do now. Computers or machines can do this by following instructions. They can do this by following what? Instructions. Now, the more data computers learn from, the better it performs these tasks. So, instructions, documented instructions is called data. The more data computers can learn from, the better it performs these tasks. Now, artificial intelligence, in a nutshell, is machine mimicking or copying or mimicking human behavior. That is artificial intelligence. Now, let us look at some examples which we talked about. Let's go to our YouTube screen. Now, we talked about that computers can drive cars by themselves, self-driving cars. Now, this is Google's self-driving car. Let's play this video and watch it.
How's your day going today? I'm sitting in the back of Google's self-driving car in San Francisco.
You can see
this is not coming soon.
There is no driver. It doesn't drive.
Just opening up to the public.
There is no driver in this car. It's a self-driving car.
And it's everywhere around San Francisco. Impossible to go 5 minutes in this city without seeing one. It's also being used in Los Angeles and Arizona too. The best part, you don't need to tip. Companies have poured billions of dollars to get to this moment.
So that's a self-driving car. Let's say a cooking robot. Let's see this. This is a cooking robot.
Here's an incredible development from the Japanese company Toyota. It's one of the first humanoid robots that excels at cooking. The culinary talents of the Motoman SDA-10 robot are demonstrated using 2 mechanical arms, each equipped with 7 joints attached to a torso.
So this is artificial intelligence at work.
And weighs a total of 220 kilograms. Thus, despite lacking legs, the robot works adeptly with its arms, mixing ingredients for pancakes in a bowl.
So you have seen how artificial intelligence can help a robot or a machine to learn how to cook. Now let's jump back into our lesson. We'll go to slide 2. Now, we are now coming to machine learning. Now, what is machine learning? This is a subfield of artificial intelligence, that is machine learning. So if you look at this diagram here, you see that you have artificial intelligence on it, then machine learning under artificial learning. Now, machine learning is the ability of computers or machines to learn from documented steps or instructions otherwise called data. So documented steps or instructions are called data. Now, machines can be trained, that's the key word, trained with instructions to carry out tasks. So machines are trained, just like you train a young child in the way he should go. You train a young child how to solve math, how to read sentences. You can also train machines to carry out tasks. That is called machine learning. This is achieved using specific software or programs called algorithms. So algorithms are the software used to train machines to read and learn from data. Now, these algorithms, otherwise called models, can learn from data and continue to produce better results the more data they consume or learn from. So the more an algorithm consumes data or learns from data, the better its outcome. Now let's make progress. The process of consuming data and learning from them is called training the model. So that to train that algorithm or to train that model is called, to train that algorithm is called training the model. Now let's make progress. Now data sets are organized structures, data that computers learn from. So when you talk about a data set, it's an organized structure of data that computers can be used to learn. Now, if we see more on the machine learning, so you discover that you have artificial intelligence here, you have machine learning, then we have the lecture we're going to talk about very soon, deep learning. The same thing goes out for this diagram and explains that. Now, let's make progress. Now, machine learning continued. Now, there are three types of machine learning algorithms. They call the programs that needs to be trained for the computers to learn and carry out tasks. They are called algorithms. So there are three types. The first is called supervised learning. This happens when labeled data sets are used to train algorithms to classify data or predict outcomes. An example is a machine can be trained with multiple pictures of cats and dogs, so it can identify whether or not a picture is either that of a cat or a dog. You can see labeled data here. It is labeled dog. Here is different cat, as much as they are different pictures, but they are still cats. This is also labeled data, talking about the weight, 18 pounds here, 14 pounds, 12 pounds, and 9 pounds. Now, those are the weights. Now, that's for supervised learning. And unsupervised, in this case, unlabeled data is used to train data to classify data or predict outcome. For supervised is labeled, for unsupervised is unlabeled. It discovers hidden patterns by itself and features from it and produces the output without the need for human intervention. The model learns from unlabeled car data. For example, a model can learn from unlabeled car data set features such as length, weight, headlines, etc., and what type of car is presented to determine what type of car is presented to it. Now, that is for unsupervised. Now, it uses unlabeled data. Now, this data here is unlabeled. You just have the picture of the dog, but it is not labeled. You have the picture of the cat, it is not labeled. Let's make progress. We also have what is called, under the machine learning, we have what is called the reinforced learning. This happens when an agent is programmed to function in a defined environment to produce actions and rewards, e.g., self-driving car used to train a model to know when to slow down, take a turn, avoid hitting an object. What does that mean? In reinforced learning, the machine is not trained directly, and the algorithm is not trained directly. It is trained through an agent. For example, that agent is a self-driving car. Now that car will now be put on the road. As the car goes to a particular point, it knows when to turn. It knows how to avoid collisions. It also knows when to slow down. That is what is called reinforced learning. The agent factor is used. Then we make progress. A trained model can make predictions on data it has never seen before. If a model is trained on sales figures for Nike, for example, Nike shoes, it can be used to predict the sales forecast for Adidas shoes in a particular time and territory. So what does that mean? if you use a trained model to train for Nike to predict its output for sales, it can be used to train for Adidas. Now let's make progress. Machine learning, in a nutshell, is a way to train AI through algorithms. So let's make progress. Now we come to deep learning. So what is deep learning? Now, this is a subset of machine learning. If you can see it from here, you see how you have artificial intelligence, you have machine learning, you also have deep learning. Now, in deep learning, data is processed at a deeper level in 3 layer levels, which are called neuron levels. The first one is the input layer, which captures a piece of information about the subject and passes it through this data to the next layer. So the first layer that captures the information for processing is called the input layer under deep learning. The second layer is called the channel layer. Now, what's the channel layer? These are different layers. It's not just a single layer by which data is further processed before it gets to the final output layer. So the channel layer, after it has been captured, the data has been captured and processed, it goes through further layers or channels. If you can look at this diagram here, you here see the input layer here. It goes through some other layers here before it finally comes out to the output layer. So these hidden layers are called the channel layers. Now, we also have the output layer, which is the layer that generates the final output, which is this, the final output. So let's make progress. Deep learning algorithms requires larger volumes of data to perform better, unlike machine learning algorithms that can function well with smaller volumes of data. So that's one of the difference. Secondly, deep learning algorithms function with high-end machines as compared to machine learning algorithms which can function with low-end machines. Then deep learning algorithms take longer time to train as compared to machine learning algorithms. Okay? Then the results generated from a deep learning algorithm is more accurate than that of machine learning. Then finally, deep learning can discover hidden patterns in groupings without human intervention. So again we have artificial intelligence on top. Under it we have machine learning. Then we have specifically deep learning, which consumes a lot of data, takes time to be trained, uses high-end machines, and it passes through the input layer, goes through the channel layers, which are hidden layers, then before it comes to the output layer. Now let's come to another topic, very interesting topic, large language models, LLMs. What are they? Are also called pretext transformers. They are machine learning models built to understand and generate human language. That is what we mean by large language models. They work by learning about patterns and language from the massive amount of text that they are trained on. Also, they take on input as text and predict the output word that is likely to follow. For example, you say the sky is. A language model will put the sky is blue. That is the predicted. As you select it, it learns from it. Now, if the user accepts the output or changes it, the model learns from it and improves its prediction next time. That's how large language models work. Then they are usually trained on large amounts of text data sets, typically pulled from the internet. So the internet becomes the data set. The whole internet, all the data available on the internet becomes the data set for the large language models. It can be used to create intelligent chatbots that can handle a lot of customer queries. It's also beneficial for content creation, to generate articles, social media posts, YouTube scripts. So large language models can help users to generate articles, social media posts, and YouTube scripts. It's also useful for software development by generating code. That's another function of large language models. It can also be used for copywriting, translations, summarizations, poems, etc. Examples include ChatGPT and Google Bard. So large language model, if you look at this diagram here, it takes text from the internet, it now interprets it in human form, the machine, and provides a human form context, like predicts the net output of a sentence or a word. This is also, you can see the same diagram here. Large language model picks information from the internet, processes it, and provides information to the user, predicts the next word to be used. Now, let's talk about generative AI. What is generative AI? Generative AI is the new content created by artificial intelligence. New content. These contents can be conversations, stories, images, videos, and music. The user has to describe in a chat dialog box what the AI should create. This is called a prompt. That means the user will type in, I want to know who is the president of the United States, or who is the president of Nigeria, or how many nations do we have on the planet. That is a prompt. That's the question. And once the AI generates it, it's now called generate. It now generates new content based on that prompt. The generative AI, which has learned and trained on large amounts of data of different topics such as languages, programming, arts, science, etc., uses the knowledge to solve the new problem asked based on the prompts. E.g., if the user makes a request for a unique logo for a brand or organization, the Gen AI can generate this from the other popular design styles it has learned from. So it is important to use the right prompts to get the right answers from the generative AI. Now, examples of generative AI include text-to-text, like ChatGPT is a text-to-text AI. You type in the text, it generates a text answer. Text-to-video, in video, you type in text, it generates a video from that text. Text-to-audio, 11 Labs, you generate a text, and it produces a sound and audio from the text generated. Then text-to-image, you type in the text, it generates an image based on that. So that is the basics of generative AI. Now let's make progress. Let's look at artificial intelligence tools, because that is a lot of what we're going to be using in these our AI basics. So let's make progress. So we have AI assistants, which are called chatbots, and they are large language models, which we just talked about, that predicts the most likely word used based on probability. Example is ChatGPT, GPT, Claude, Gemini, DeepSeek, which just came out recently, Grok. We have grammar and writing improvement AIs like Grammarly and WordTune. We have video generation and editing AIs like Synthesia, Runaway, Filmora, Opus Clip. We have image generation AIs like Midjourney, DALL-E 3. We have graphic design AIs like Canva Magic Studio Lookup. We have presentation AIs like Gamma Presentations.ai. We have voice generation AIs like 11 Labs Morph. We have music generation AIs like Suno Idio. We have research AIs like Deep Research. There's also writing AIs like Write, Pseudo-Write, like Write, Pseudo-Write. We have search engines like Perplexity, ChatGPT Search. You also have social media management AIs like Visa Social, FeedHive. There's also app builders and coding AIs like Bubble, Boat, Lovable, Cursor, VO. We also have project management AIs like Asana, ClickUp. We have customer service AIs like Tidio AI, Hiva. You also have email AIs like Hotspot Email Writer, Sanebox, Shortwave. You also have resume builders like Teal and Cake Resume. Then finally, you have marketing AIs like Ad Creative. So these are the AI tools that are available, which we're going to be working in subsequent lessons. So I feel now you have a basic understanding of what AI is, what is AI, what is deep learning, what is AI, machine learning, deep learning, generative AI, and artificial intelligence tools. So that is it for the introduction. My name remains Vincent Hope. If you have any questions or any comments you want to make, please feel free to drop your comments or make your requests or ask your questions. See you. Thank you for watching.